Okay, so here we have a prototype of my USB power control rig, which I'm going to be using for IoT firmware testing. So we've got a mains adapter here, which is stepping down to 5 volts. This goes through to control a Raspberry Pi here, which is managing the system. The wires coming out of the Raspberry Pi are going to an 8-way relay module, and these massive wires that we have coming out are breaking out the 5-volt power to a couple of 4-way USB strips, and we've got some test microbits attached to a few of the outputs so that we can see everything working. Over on the Raspberry Pi side, for some testing, we've got an install of Raspbian, we've got Python, we've got some Python scripts. And if you can see this line here, we're going to run a script to turn relay 1 on. And what's going to happen is the LED for the appropriate channel is going to turn on the relay board, and with a bit of luck we'll have powered one of the Raspberry Pis. So let's try that. Here we go. There we go, it turned on, and look at that. Channel 1, Raspberry Pi, it's turned on. Now we've got a microbit rather. Now we've got a microbit attached to channel 3. So if I turn channel 3 on, boom, that's running as well. Let's turn 1 back off, and it's gone. If we want to turn 8 on, here we go, and it's running. Obviously you can have any combination of these, so we go back and we turn all the relays on. There you go, everything's running. Round of applause. Turn them all off again. Everything's gone. So this is one of the most basic things that we can do. We can turn on and off individual embedded systems, and that means that we can set them into a known state. We can do power cycle testing of firmware, and we can do all of this remotely through internet connections into our Raspberry Pi. Next step is to get all of this boxed up and start developing the software to manage firmware updates.